Hello everyone, I'm Tanab Bukaria and today I want to share a reflection on my recent self-running assignment or activity as a part of my professional development. The goal was to go deep into foundational topic, and for this I chose a two-part activity. First, to actively research and write an in-depth article about Android versus iOS, and then I created a video explaining the magic of memory management in our OS or PC, which we use daily in our life. So let's jump into article first. This is my LinkedIn profile. I've uploaded my article here. This is the article. So it's titled "The Mobile Titans: An Operating System Comparison of Android and iOS." The article. I chose this combination because understanding operating system is one thing, but seeing how they manage their most critical resource, memory, is much deeper practical skill. So let me first walk you through my article. My learning process here wasn't just passive reading; it was active research, synthesis and creation. My first step was to move past the surface level Apple versus Google debate and understand the core architectural differences. I used resources like official developer documentation for both Android and iOS, as well as technical breakdowns from engineering blogs. Uh, First, core philosophy. We explored open hand versus the walled garden. The single most important difference between Android and iOS is their core philosophy, which dictates every technical decision. The Android is known as known because of its openness. Like you can download anything from Google. You can download external apps like 9apps Pro and TuTube app, etc. Where it's like an open source uh, versus the walled garden of iOS. It is a closed source proprietary operating system that can only be installed on hardware of Apple. So like anything you want on Apple can be done through its Apple Store only, and you can't install any external from external sources. You can't install APKs, and there are a lot of restriction in that. The second, kernel architecture. This was the most technical part. Uh, I learned how Android relies on monolithic battle-tested Linux kernel, while iOS uses XNU hybrid kernel, which combines a Mac microkernel and components from BSD. This directly impacts everything from driver support to system security. Now the third one is how apps run. Virtual machines versus the native code. I researched the execution environment, contrasting Android's use of Android Runtime ART, which translates bytecode into native machine code, with iOS's approach of running precompiled native code directly. Uh, then the main part is the ecosystem. Fragmentation was integration. The This is where the philosophy and architecture have real world differences consequences. I detailed how Android's openness leads to fragmentation, which is a challenge for developers and security, while Apple's integration provides seamless updates, optimized performances at the cost of user. So this was my article based on Android versus iOS, and iOS thrives on integration because Apple is the sole provider of both hardware and software, and thanks to the App Store, its ecosystem is highly cohesive. The developer benefits. iOS have developer benefit and security advantage, whereas uh, Android has developer challenge and security challenges. In conclusion, though Android and iOS effectively achieve the same end of running a modern mobile computer, they are diametrically opposed ways of getting there. So like it's your choice whether you want to have something that is open source, like you can download APKs and have don't have restriction, but it leads to security threats. Whereas or else you want an integrated system that is keeps on upgrade that is seamless. Like if you open a browser on one device, it can also be directly accessed through the other. Uh, writing the article gave me the what and the why of OS design to understand. Now to understand how I turned to this video on magic of memory management. My learning process here was to watch the video, take notes, and then apply these concepts on my article on Android and iOS. So the video provided me a fantastic breakdown on some topics like how the stack is used for static memory and the heap for the dynamic memory, the concept of virtual memory, and how the OS uses page tables to keep processes isolated, the difference between manual memory and management and automatic garbage collection. This video was the perfect practical complement to my theoretical article. So, what skills did I learn from this combined activity? Technically, I have gained a deep comparative understanding of two of the most dominant operating system on the planet right now to the kernel level. I also solidified my knowledge of memory management, which is a fundamental concept in all of computing. In terms of communication, writing the article forced me to take highly complex abstract ideas and distill them into a clear, accessible language supported by visuals. This is a critical skill. Professionally, this entire exercise was a masterclass in self driven research, critical analysis, and technical writing. It's one thing to learn a topic for a test, it's another to learn it well enough to teach it, which is what writing an article forces you to do. How will this experience help me in my future? For placements, compare Android and iOS architecture or explain memory management are classical or technical interview questions. I can now answer those with incredible depth and confidence far beyond a textbook definition. For my career in cybersecurity, this knowledge is not just nice to have, it's essential. Understanding kernel differences, app execution, memory layout is the very foundation of vulnerability research, malware analysis, and mobile forensics. You can't secure a system if you don't know the system. For hires, this project has given me a strong foundation to explore advanced topics like secure OS design, reverse engineering, or creating more efficient secure applications. Ultimately, this self-learning activity proved that by combining active creation with focused learning, I can build a deep practical and career ready understanding of complex technology. So that's all, and thank you for your attention.